So we're going to look at subtracting fractions today, all right? I've got a few examples here that I like to do, and I'm going to draw some pictures as well for a few of them just to hopefully give you a visual picture of what's going on. You see how we have 9/10 and 3/10 for the first one here? What can we do when we subtract fractions? What do we need to do? Anybody? What should we do? Okay, how do we do this? Someone help me out. Elias, want to help me out? Oh, no? Help me out, somebody. Yes. Right, so when the denominators are the same, then all you need to do is just subtract the numerator. So 9 take away 3, what's that? Well, that's just 6, so 6 out of 10. Now, if you want a visual picture of what's going on, 9/10 is like, remember that big rectangle that I like to draw? I'm going to split this up into how many pieces if it's 9/10? 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 9/10 mean I shade in how many of them? 9 of them. So 1, I'll just shade them all like this. Okay. Now, when I'm taking away 3 of them, I'm just saying to you, let's take away 3. Let's get rid of this one. So remove, remove, remove. And what's left over? Of course, this is what's left over. That's our answer. So it's 6. 6 out of 10. Now, ladies and gentlemen, leave your answer like that, and I'll mark it wrong. Why? Lowest terms. Thank you. So what number is easily divided by both 6 and 10? 2. Good. So divide both 6 and 10 by 2. You get 3 over 5. And now I'm happy we're done. Okay? All right. Let's try B. Okay, this one's kind of weird because now we have a 2 by itself, a whole number, minus 2/3. So what's up with this? If I were to draw a picture, how would I draw 2 holes? That'd be 2 rectangles, right? All shaded in. That's 2 holes. How do I take away 2/3 then? Well, do you even see thirds here? Not yet. But what I can do is I can split it up into thirds. And now I'm saying let's take away how many of them? 2 of them. So goodbye, goodbye. What's left over? Left over is this. How many thirds are left over? 1 whole and 1/3, correct? Or if you like to just do improper fractions, I see 1, 2, 3, 4. 4/3. Correct. So write that down, please, and I want you to draw a picture for this one. And then afterwards, I'm going to come back and actually show you how you can do this without pictures as well. Okay? But I want you to see the pictures for this one so you can see what's going on. Okay? So quickly draw this in, please, if you haven't done so already. And then we'll show you how to do this without pictures. Okay? So I'm going to give you some space here. Whee! I'll say, let's do without pictures. Ladies and gentlemen, like what one of your students said here, you can't subtract unless the common denominators unless the denominators are the same. Can someone tell me what is the denominator of this whole number 2? If I wanted to write this as a fraction, that's the same thing as 2 over what number? Yes, Gajo. You sure? 10? 2 over 1, yeah. That's the same thing as 1 whole. So this is the same thing as 2 over 1. So if you just have a whole number there, if you want to write it as a fraction, just put it under 1. So my question to you is, are the denominators right now the same? Is 1 the same as 3? Yeah? No way. So let's make them the same. What is the common denominator between 1 and 3? What? Oops. 6. 6 is good, but is there a smaller one I can use? Just 3, yeah. So why don't we, once again, rewrite them. So I'm going to say rewrite with a common denominator. And the common denominator between 1 and 3 is really just 3. Okay? Now, your job is to figure out what number goes on top. So remember how we did this last day with adding fractions? It's the same here. 1 times what gives you 3? 3. Good. So then 2 times 3 gives us 6. Awesome. How about this one over here on the right-hand side? Not the right-hand side, the second fraction. 3 times what gives you 3? 3 times 3 gives you 3? 3 times 1. Thanks, Natasha. And so 2 times 1 gives us 2. It's the same thing. Okay, now when the denominator is the same, what do we do with the numerators? Let's subtract. So what's 6 take away 2? That's 4 over 3. Okay, or if you like mixed fractions, 1 and 1/3. Same. Okay. Okay. Gabby, you writing this down? All right, ladies and gents. So the idea of subtracting fractions is the same as adding. We need to find the common denominator, and then let's subtract. Okay? So here we go. Let's try part C. Are the denominators the same? No. So what can I do to make them the same? Yes, Dale. Times them together. Good. So what's 5 times 3? 15. So Dale says, let's rewrite our fractions with the denominator of 15. Awesome. Okay. So with the fraction on the left, can someone tell me 5 times what gives you 15? 5 times 1? That's 5. 5 times 3. Good. So what we do to the bottom, we better do to the top. So we'll take our numerator, which is 4, times 3 is 12. Thank you. And let's do the same thing with the 3 over here. 3 times what gives you 15? That's right, 5. So the top is just 1 times 5, which is 5. Excellent. Why can't I get red? Here we go. Now, what's 12 fifteenths minus 5 fifteenths? 7. 7 fifteenths. Congratulations. Done. Okay. Straightforward? Feeling good? Okay, let's try the next one then. This one I've got whole numbers in front. Ew. Don't worry. Let's do them separately. Okay, like the adding of fractions. Let's do these separately. Let's do 7 take away 2. Let's do that separately. And let's do 3/5 take away 1/3. Let's do that separately. Okay? Separate them. Let's do the easy part first, shall we? Right, Dawson? Do easy stuff first, right? So what's 7 take away 2? 5. Awesome. And then now we have 3/5 and 1/3. Ew, the fraction denominators are different again. What can we do now to make them the same? Yes, Jumana? 15, she says. Congratulations. 5 times 3 is 15. So let's go ahead now and rewrite each of our fractions using the same common denominator. And what will this be? 5 times what gives you 15? 3, thank you. So we do the same thing with the top. 3 times 3 is? 9. Well done. Somebody else help me out. 3 times what gives you 15? 5. So we do the same thing at the top. 1 times 5 gives us 5. Awesome. Now the denominators are the same. I can subtract them. Life is good. 9 fifteenths minus 5 fifteenths is how many fifteenths? 4 fifteenths. Well done. And then don't forget we said the 5 in front, so our final answer is just 5 and 4 fifteenths. Does that make sense? Cool. And of course, Mr. Lee saves the best for last, right? Okay. Well, the last one looks similar to D. So why don't you start and see if you can at least start this question. What do you think I should do first? Separate them. Good. Let's separate the whole numbers. 4 take away 2. And then we'll do the fractions. 1/8 minus 3/4. Okay? Awesome. Okay. What's next? What should I do next? What should I do next? I should relax and drink coffee. No. Yes. Okay. New one says find the common denominator. Okay. What then is the common denominator between 8 and 4 since they're different? 4? 32. Okay. 32 works. But is that the lowest one? I just like the lowest one because our numbers are smaller. You can make 32, that works, but then you have to simplify afterwards. Yes, Clarissa. Can we do 8? I think 8 actually works, yeah, because look, the multiples of 8 are 8, 16, 24, 32, like what you guys said. Multiples of 4 are 4, 8, 12, 16, 20, 24, 32. So 32 works, but it's so big. Clarissa's like, Mr. Lee, do something easier. 8 is also in both lists, so use 8. I like that. I like small numbers. So, can you please change all these to 8? Okay, our denominator has to be 8. What's the first fraction then? 1/8 is equal to how many eighths? Yeah, just 1/8. It's 1. And then how about this other one? 4 times what gives you 8? 2. So then I do the same thing with the top. What's 3 times 2? 6. Okay. I don't like this. Abby doesn't like this either. Why?
You can't subtract a number because it's too big.
Yeah, 1 take away 6. I've got $1. You want to take away 6 of them? I'm like, I don't have that much money. Okay, wait. What can we do? Hey, do you remember this other part that we didn't do yet with the whole numbers? 4 minus 2? What's 4 minus 2? 2. Okay, so this whole thing equals a 2. Now, here's our dilemma. Problem here is how, and don't write this down. I'm just going to say how, I need pencil. How can we subtract 6 from 1? And the answer is, we can't. So we're in trouble, aren't we? What can we do? Yes, Gadjo. What can we do? Switch the numbers? What do you mean?
Like swap.
Swap them?
Yeah.
And that's the answer? So Gadjo's thinking is, let's swap. So for example, if I gave you 10 minus 3 and 3 minus 10, they're the same thing? Yeah. No, but good idea, but not so great here. Abby, yeah.
One of the whole numbers.
Uh-huh.
So you can subtract it.
Right. Okay, listen and watch first. Don't write this down. Just watch. Do you remember the 2 whole? What does that mean? That means I have 2 rectangles that are all whole pieces, right? And then what am I doing here with the eighths? I'm saying to you, can you split these up into eighths? Well, if I split them up into eighths, look what happens. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's kind of like how we did subtraction like this. Just watch. 25 take away, I don't know, 17. How do you go from 5 minus 7? How do you do that? You can't. You borrow from the other one, right? So you kind of change this to a 1, and then this becomes the number 15. Well, that's what I'm doing here. I'm asking you to borrow. I'm asking you to borrow one of these whole numbers, which is equivalent to what fraction here? How many parts do we have? 8. And then we have all of them shaded. It's like 8 eighths. That's right. So the key thing here, and I'm going to ask you to write this down now, okay, is to deal with our dilemma, we need to do the following. We need to borrow something. What are we borrowing here? Well, what we're doing is we're borrowing 8 eighths. Okay? So we're going to borrow, in this case, we're going to borrow 8 eighths, so 8 out of 8, and put it together with the 1/8. Okay? And this is the one where this is very confusing, I understand. I'll show you one other way to do this one too afterwards, if you don't like this confusing borrowing way. Okay? Yes. Is it 1 3/8? We'll find out. Okay. All right, ladies and gentlemen. So when we borrow, let's see what we get. What does this become now? The 1/8, and if I put together with it the 8 eighths, what's 1/8 plus 8 eighths? 1 plus 8 is 9. Good. So this becomes 9 eighths minus 6 eighths. What's 9 eighths minus 6 eighths now? 3 eighths, right. And so finally I've got a nice fraction 3/8, but what's my whole number in front? What's my whole number in front? Yes, Gajo. Yeah, no longer 2, because I borrowed one of them. The answer is 1. 1 3/8. Okay? Now, ladies and gentlemen, I know this way might be a bit confusing for some, so let me show you one more way, and then we'll stop the subtraction part. Okay? The other way of doing this, okay, is I'm going to ask you to change, and please write this down as well, so I want you to have this in your notes. Change the mixed fraction into improper fractions. Okay? So this is a common way of people doing this as well. If you like this method, then go ahead and try. If you don't, then please don't. Okay? Change mixed fractions into improper fractions. That's what I'm asking you to do here. Okay? I hope you have some space still. Okay. Can someone help me out by changing that first fraction, 4 1/8, into an improper fraction? So how can I do that? We had this, right? 4 1/8 minus 2 3/4. So how can I change this into an improper fraction? Somebody help me out. Remember how to do this? The 4 1/8. Yeah, Abby, sure. Good. So 8 times 4 is 32, plus 1 is 33. So the first fraction now becomes 33/8. Okay? How about the next one? This is in fourths, so same idea. We take the denominator of 4, multiply that by 2. What's 4 times 2? 8. 8 plus 3 is 11. Good. Okay? And so when we have changed this into improper fractions, then you don't have to split things up. Okay? Now, look at our denominators, and are they the same? No. So just like before, I like you to change it into a common denominator. So what common denominator should I use here? 8, thank you. So notice the first fraction stays the same. What's wrong with my computer? Oh my goodness. It's going on in Fritz. It's not responding. Ah. Anyways, we'll do this verbally. 33/8. How about the next part? What does that become? Let's see if I do this on the board. 11 times 2. Good, which is? 22. Yeah? So I'll do it over here, ladies and gents. So we have here, you can't see, 33/8. And then it becomes take away 22/8. What's 33/8 take away 22/8? 11/8. Huh? Well, too bad for them. 11/8. Good. And if you were to change that to an improper fraction, what would that be? What would that be? What would that be? What would that be? You guys forgot? Remember we do the division here? So just go ahead, quickly divide. That goes into 8 once. We subtract, you get 3. The same answer as before. Okay?